Welcome everyone, and thanks so much for joining us today. This session 1.1 of our Tugger Toolkit series, and we're going to kick off things today with a topic that sort of sits right at the heart of great Power BI work, and that is Star Schema architecture and data model integrity. Over the next 30 minutes, we're going to look at why the Star Schema is the right choice for Power BI, how to design models that are fast, maintainable and scalable, and how to structure your dimensions and fact tables so your reports hold up under real world pressure. If you have any questions as we go, drop them in the chat and we'll get to them at the end. I'll now head straight over to Tim. Tim, over to you.
Hi everyone. I'm not going to be quite as well scripted as Craig, but welcome. So as you said, we're talking about Power BI, and there's a series of 6 at the moment that's planned, starting off with kind of building the model, which in my opinion is the most important step. Once we build a good model, then everything else becomes a lot easier down the line. So introducing me a bit more, I'm Tim. I work at Tugger and I'm the Power BI developer. So what that means is, I don't know why it's moving like so, but as a company, we are building out connectors to connect you to your data directly from the API all the way through to Power BI reports. So in my role, I'm helping build the models and the templates and also some bespoke reports for our customers. So starting off with the Star Schema, I thought it'd be good kind of as a layout to always start off with what is the problem. This is kind of going to be my approach going forward with the webinar, is problems that I've kind of had to face and then how I resolved them. So starting off today is the cost of chaos. If any of you have worked with data, you're working with Power BI before, you've probably seen data come through in lots of weird and wonderful ways, some more helpful than others. So we can start with the source data. You might want to choose to keep that, or you might want to choose to change it. So most of the time, I believe we can make it a lot better for Power BI specifically. Data models are built in warehouses for storage capacity and helping with that and making things easier for them, but it's not necessarily going to be best and easiest for us on the analysis side of things. So we might want to change it for that reason. And that's because source models might be slower for Power BI. Which being slower would result in more expensive hosting if you're hosting your reports. It can also make your models quite confusing for anybody to look at and especially difficult to maintain, largely because it's quite confusing and it's difficult to know where things are. And it also makes things harder down the line when it comes to building out DAX measures, calculations to get to the answers that you want for the questions that you have. So here's an example. This is actually a relatively nice source model, but we can see we have what's called a snowflake model. You may or may not be familiar with that, but it just means that we have tables relating to tables relating to tables. We have these different levels, making the model a bit more complicated. The goal for us today, and to explain to you a bit about why and how to do that, is to simplify that a bit into a more pure Star Schema model. So this is what we call a Star Schema. Don't worry if you don't know all these words, I will explain a bit as we go forward. But generally, this is our goal, to go from something a bit more complicated to something simpler, which will hopefully make our models faster, our reports quicker as well, and cheaper as well, and even easier for AI to understand, for people to understand, all around hopefully a bit better. This is an easy example. We can also, you might have seen models that look a bit more like this, a lot more crazy, a lot more tables going on, a lot more relationships going on. Again, we want to simplify that and bring it into this more star model that we have on the other side. So what is our topic for today, or our mantra for today, we'll call it? It is to build for Power BI and not the source database. So it's all about how we can make it better for Power BI and not just relying on how the model came to us, whether that be some Excel spreadsheets that were flat all in one table, or whether that be you've done it from the API and you've got 20 tables that you want to deal with, or even 200 we've had as well. So going forward, what is the Star Schema? I've mentioned it now a couple of times already, so did Craig. You've hopefully have heard of it, but if you haven't, don't worry. It's very important in the analysis world because it's the golden standard for building reports, for analysis, for the reasons we've mentioned before. And it's called a star schema because it has this kind of layout where in the middle you have your facts. These will be your numbers, the things that you're going to be adding up, averaging, all of those things go in this fact table. So that could be, for example, your sales, your costs, your payments, those kind of things would all go in here. The goal of this fact table, which we'll explore a bit more, is that it should be tall and thin. What that means is it's okay to have lots and lots of records, but it's best to not have lots and lots of columns or fields. It should have lots of numbers in it. This is all about numbers. It's not about text description. And then it will also have what we call foreign keys, and this is just to help you relate to the different tables. So on the outside, to explain that, we have also dimensions. Dimensions, this is all about the context. This is about describing things about your facts. So when it comes to sales, for example, you want to describe what is the name of the sale, who was it sold to, where was it sold. So those kind of descriptive things. So we have our whos, we have our whats, we have our wheres, our whens. And then another important element of the star schema is our relationships. So in SQL, that would be joins. In Power BI, it's relationships. We're building a relational model where all our descriptives all point towards our facts in the middle. The point of that is all about filtering. It's being able to filter by any of our descriptive information to filter our facts. So we might want to filter by what kind of sale we had to look at the numbers of our sales. We might want to filter by when our sales happened and then look at those numbers in the middle. So that's the core idea of a star schema. In the middle, we have our facts, and on the outside, we have our dimensions. If any of you are familiar or have tried doing this, it obviously gets a lot more complicated and messy in the real world when you start having to make choices about what goes where and what kind of layout to go. So that's kind of the goal of this course. It's not necessarily to give you all the answers, but I think to give you pointers in what direction you might want to take or be aware of the different ways of thinking about things. I know me personally, I'm using AI quite a lot, and I imagine a lot of you are too. And AI is very good at getting you quickly to an answer that does something that you want, but it's not necessarily good at getting you in the right way. So it's important for us to kind of be aware of the different options that are out there, the pros and cons of different choices, so that we can kind of better assess the approaches that maybe the AI is taking for us, if we're trying to do things a bit faster. But also generally be aware of these options so that we can improve our models and prompt AI better in the first place. So yeah, going forward, here's an example for you, like I was talking about sales. So in the middle, you might have all of your sales information, your numbers about like the costs, the amount, that kind of thing. And then on the outside, we'll have these tables about descriptive things. So we might have our customer, who are we selling it to? Our employee, who is doing the selling. Our store information, where is it being sold? The product information, which products are being sold, the names of them, etc. And when, the dates. Lots of information about dates. Okay, and here's a better example where you can actually see what this looks like directly in Power BI. Okay, moving forward. So I thought we'll delve deeper into the star schema and the choices that we have to make whilst building one over the next 5 topics of this webinar. This one is more of an introduction to what are the key rules that you might want to think about when wanting to make choices about how to build your model. So these are kind of the things that I think about whenever I get a new model I want to attack. These are the things that I try to build my choices on. And every time I make a choice, I'm thinking back to these 4 rules. Am I breaking any of these? If I am, is there a good reason to? So these 4 rules that I follow are, which I'll explain briefly afterwards, is the same fact grain. So this is all about having everything that's facts on the same level. There are similar facts, they would all come together. We don't want to overcomplicate with lots of tables. Thin fact table, briefly mentioned this before, it's about having not loads of columns and just trying to make it less columns and more rows. Reason for that is because Power BI is best at dealing with that. And then the third rule is about one table dimensions. Avoid having as many tables as avoid having loads of tables. The fewer tables you can get things in, the better, and less necessary. There's loads of advantages for having more tables, and that's something we'll also explore more later on in the course. And finally, no messy joins. This is about making sure we are doing our joins properly. We're not doing many-to-manys, for example. It's probably something many of you have heard about, but we will explore a bit more in detail as well. So starting with rule 1, same fact grain. What do I mean by this? The best practice here is all about, if you have multiple tables that are talking about the same business process and they're on the same level, so one row is the same level as the other row on the other table, then we can put it in the same fact table. So I have an example here. This is from HR data. You might have information about holiday leave, absences, and then information about sick leave. Maybe from your source data, which is what happened with me, they're in 2 different tables. But I chose, you know what, they're both speaking on the same level. They're both the same business process. They're both about people not being in office, about people taking time off. So I decided, you know what's simpler for my model? Why have 2 tables with loads of relationships when I can just have 1? So I joined them up into 1 table. In this case, I did it on a daily level, and that's just because I wanted to be able to see very easily daily whether people were in office or not and why. So that's kind of rule 1. Try to unify anything that's on the same level onto the same table. If it's not on the same level, it definitely shouldn't be on the same table. And if it's not talking about the same business process, it should not be on the same table. Again, this is something we'll explore deeper because there's a lot of debate about what should and what shouldn't be combined, but generally just try to think about that. So if you ever come across these kind of things, maybe it's worth prompting your AI and asking, I've heard that it's best to keep things on the same fact grain. How can I do this with my model? Should I be combining these or should I not be combining them? And then maybe that will help you out understanding what the best approach is for you. Second rule, thin fact table. So like I said, this is about making your table less columns, but we don't care about it being really long. We just don't want it to be really wide. So how do we do that? We are removing all our descriptive information from our fact table. So those who's, what's, where's, when's that we talked about, those are dimensions, right? So these go in the tables on the outside. We take them out of the fact table and we put them on the outside. In source tables, you will always have, almost always at least, they'll be mixed up. You'll have these descriptives inside tables that also have your facts. So it should be our job to bring these out and separate them. Why are we doing that? That's because our fact tables are usually our biggest tables. And so we want to keep them smaller because the bigger tables are also the most expensive tables. They're also the ones that take the most time to load. They're also the ones that take the most time to interact with when we're clicking on buttons on our report. So that's why our focus is to keep those as small as possible and push the descriptives outside. Another reason is descriptives, so things like who, what, where, when, are repeated a lot. So for example, you might have the customer name. So we have the sale transaction, right? And then we have the customer name over here. We're going to have that customer name repeated like 10, 20, 100, 1,000, million times. We're wasting rows. In a descriptive table, we only need to have customer 1, and then the name once. So we're saving space as well as making things a lot faster. So as I've shown here, bad example is having a customer name and a customer address inside our fact sales table. The best way to do this would be to, instead of using the whole name, use the key. So that would be like the number 1, 2, 3 that tells you which customer, and then have a separate table called dim customer, whatever you want to call it, where you have this descriptive information about the customer. And then you can have all these extra descriptive things about the customer, like their name, their address, without taking up loads of space in your already very big fact table. Another example, so going back to the HR example I've been talking about, this was an actual model that I had to build from. So in the yellow, we have all sorts of descriptives. These are the ones that I would look at and go, are these even necessary? Do these help answer any business questions? In my case, I think the answer is probably no. So these ones I'm actually removing. They're a waste of space, a waste of time, a waste of money. And it's just a bit of a headache having all these extra columns that we don't need. The blue ones, these ones we might want to keep actually, but these are still descriptives. So what am I doing? I'm pulling them out and putting them in dimensions. So the leave reason is going to a leave reason dimension. Type is going to leave type dimension. Cancelled is going to a status dimension. And that way we're keeping our fact table about absences really simple, clean, and just about the facts. Rule number 3, one table dimension. This is a bit like the fact one. Again, we're trying to simplify our model. We don't want 7 tables when we can just have 1. It's not the same for source systems. They want the 7 tables because that's cleaner. But for us, we want our measures, our calculations to be simple. We want our filters to be simple, to not have to pass through loads of tables because that slows things down. So we're avoiding what's called snowflaking. So snowflaking is what we see here, where we have our facts, we have a relationship to our dimension, and then our dimension again has another relationship with other dimensions. The problem with this, once it starts getting bigger and bigger, especially, and you have lots and lots of data, is how filters travel through this. So what it means is if we want to filter by salary, it's filtering this table, which is then having to tell this table to filter, the employee table, which is then having to tell the absence table and the sickness table how to filter. So instead of just employee filtering absence, we're having to filter every table along the way, which is why things might get slower. So what do we want instead? Let's put all of these 6 attributes, descriptive things about the employee, and bring them all into the employee. The salary is talking about the employee. The division is talking about where the employee is. The location, this is just about the employee. This is all information about our employee. It doesn't need to be outside of this table anymore. So we can bring all that in and make everything a lot simpler for us building our reports afterwards, or for someone else, in my case, to build them afterwards. Okay, and then finally, our 4th rule going forward is all about no messy joins. Joins is our relationships from tables, dimensions to our fact tables. We do not want these to be ambiguous, unclear for our model to understand, because this can break things. They just might not work properly. So the key rules here for a true star schema is to always use single directional relationships. So I mean filtering, so they filter one to many from a table on the outside, a dimension, to the fact. We never want to have a cross filter where the fact table is also filtering the dimension. It's almost never happening. There are times when it's necessary, and we'll look into that. But as a rule, we want to have the dimensions filter down to the middle, and that's it. Another key rule is if we can have more than one fact table. We can have lots of stars flying around, you know. We don't ever want a fact table, a table with numbers in, to be related to another fact table, a table with our fact numbers in. Because again, we're confusing relationships. The model doesn't know how to pass relationships from dimensions to facts, and then also from facts to facts, and then to their dimensions. It starts getting very messy. We only ever want dimensions relating down to facts. Another thing you might come across where mistakes happen is the typing of keys. There's a big debate amongst people about whether we should be using only numbers, integers for keys. In Power BI, it doesn't really matter, but what does matter is that they are explicitly defined. So in Power Query, or whether you're using the buttons or you're typing it, you'll want to be making sure to tell your computer, this is a date column, this is an integer column, this is a text column. Why? Because it just means you're not going to run into problems later down the line if it starts guessing the column types wrong. Because if it thinks they're different column types, they can't have a relationship anymore. So example, we have our fact items going down to our, that should be the other way around actually, sorry. Dim status should be related to our fact items. So better example we see on the side here, we have our fact about leave. Each line is a day and how long they took off of that day, and which employee, keys, all the information in keys relating to our dimensions. So always pointing in. So you see this one to many, pointing towards the fact, one to many, one to many. Nothing here is filtering both ways. Nothing here is many to many. Okay, so just to kind of show that a bit clearer, we have our date key, which is relating to our date key in our fact table. Our employee key and employee relating to our fact table as well. This is just so that your model knows where to find information and how these tables are related without having to put all that descriptive information inside the fact. So key takeaways from today. I will put this, I think this PowerPoint will be available and so will a recording. So I've got a bit of information about words I might have used that you might not understand. We use a lot of jargon, I think, in data, so feel free to review that. But generally, the key takeaways are we build for Power BI. We do not build for the source database. What that means is we don't care how the data came out of source. We care about what it's being used for, which is analysis in Power BI in our case. But it goes for any kind of, if you're using Tableau or anything like that. We want to build it so it's best for analysis, which means Star Schema. Star Schema is the gold standard. And what rules can we follow to help make modeling choices to build this Star Schema? Have the same fact grain. If they're on the same grain, put them together. If they're not, put them away, separate. Make your fact tables thin. Get rid of all those text columns inside your fact table, put them outside into dimensions. And third rule, keep your dimensions simple if you can. If you have lots of information and lots of tables about employees, put them all in one employee table. We don't need 7 tables relating to it. And finally, keep your joins clean. Always do one to many from dimension tables to the fact table. These are the key rules, and we will be exploring in future sessions a bit more about specifically how to make choices about the fact grain, so number 1, and then also about number 3 and number 4, less about how to make those choices really about what goes where in the model and why, and what are the pros and cons of the different choices, because these rules are flexible. Building a model is always dependent on what your use case is. So we'll explore more about how you make those choices with specific examples. But generally, these are my go-to. So if I have a question, if I'm building my model, and I've asked maybe Claude or Gemini, give me an idea of what model maybe I want for this, I immediately can go back to it. Wait a second, you've put 2 things that are different, that are the same fact grain in different tables. Can't we put them together? Or you've put 2 things that have different fact grains in the same table. That's not allowed, is it? We can't do that. So we can start being more aware of the issues we might come across in model building, so we can make better choices, make our lives easier down the line. So like I said, what's coming next? Now we've kind of done a very brief whistle-stop tour of the Star Schema, what it is. But next we'll talk more about the fact granularity. So this is our rule 1, and how that works in real-world choices about what should be in 1 fact table, 2 fact tables, 3 fact tables, etc. And then we'll progress from there. So that's kind of concludes today. The goal was to only be 20 minutes. I think I went a little bit over, and to allow the last 10 minutes for talking, for any questions you might have. So let me know now if you have any questions. I don't know if Craig's seen any yet in the chat.
Not got any questions at the minute, Tim, but we'll just see if anyone wants to ask anything. But yeah, I mean, that were a great talk, was that. Brilliant going through that. And I think one thing I wanted to mention, just in case, just gives people time to ask a question if they need to do that, is we've also at Tugger we've released a new feature that we've called AI Insights. What this allows you to do is ask questions of your business data in plain English, so no SQL, no dashboards, anything like that. And that hooks up to multiple data sources, so whether that be Xero, HubSpot, Simpro, or whatever. And the way you interact with that is through tools like, Claude, ChatGPT, Gemini, Copilot. So the sort of tools that you'll be using sort of day to day. And if the people are on the call that are already using Tugger, that feature is already available, so people can go and link that up as of now and start to use that tool if they want to use that. I mean, if people want to learn more about it, they can literally jump on the website, and there's in the top menu bar there, you've got a link there that just says AI Insights. You can click on that to find out more, and then we've obviously got documentation around how it sets up. But yeah, but I think looking at it, we've not got a lot of questions, just a few thank you messages there, Tim. So I think we will leave that there. Yeah.
Appreciate it. Let me know. I guess you can find me on LinkedIn. So here's my information. You can also find more information about what the webinar is coming up, and also when we upload it, this is how you'll access it. The website is here at tuggerapp.com webinars. Feel free to email me, contact me if you have anything that you'd like to be covered in the future as well, or feedback in general, something I could do better. This is actually my first ever webinar, so feedback would be greatly appreciated. But thanks all for coming. I hope it was helpful. I don't know if Craig, you have any final words?
No, just other than to say, thanks all for taking the time out of the day to attend. And again, Tim, yeah, good. You've done well for your first webinar, so don't worry.
Hopefully we'll see you all next week. That's the true test, isn't it?
Brilliant. All right. Thanks all. Bye.
Thanks.